the Pythagorean identities, there are some double angle formulas. So for the double angle formulas, I'm thinking, now these have not come up in class yet, but they will. Sine 2x, or this one has not come up. Sine 2x equals, anybody remember it? 2 sine x cosine x. So that's one that we're going to be using in calculus. And then cosine 2x, there are 3 versions for cosine 2x, and one of them is cosine squared x minus sine squared x. If I used my Pythagorean identities to substitute in here, if I use that one for cosine squared x, which is 1 minus sine squared x, I might do that on the side. Okay, cosine 2x. Here, if I said, okay, I know cosine 2x is cosine squared x minus sine squared x. And up here, I had cosine squared x is 1 minus sine squared x. I can put that in for cosine squared x. Then I have 2 like terms, negative sine squared x and negative sine squared x. It's because those parentheses are really not serving any purpose. And in fact, I'm going to get my pink pen out and say, remember I can always put a coefficient of 1 in the front. Minus 1 sine squared x minus 1 sine squared x. So that's 1 minus 2 sine squared x. So cosine 2x can be written as 1 minus 2 sine squared x. Also, I could have, instead of substituting for cosine squared x, I could have substituted for sine squared x. Sine squared x is 1 minus cosine squared x. And had I done that, I would get 2 cosine squared x minus 1. Okay, that would probably be a little bit more interesting to show. I would have to worry about a sign change in that one. So you can do that. You could say, okay, let me go back here and substitute instead for sine squared x is 1 minus cosine squared x. This minus sign would distribute, and it would give me positive 2 cosine squared x minus 1. So there's double angle identities. And what I did in class is I took, well, you see, I have 3 choices here. Somebody in class did ask, could I have used any of them? Yes, I could have used any of them. But if I'm trying to solve, say, for sine squared x, I could pull this guy. Cosine 2x is 1 minus 2 sine squared x. And rather than the other 2, because this first one has cosine squared x in it, and if I'm solving for sine squared x, this is kind of in the way. And if I'm solving for sine squared x, well, this one doesn't even have sine squared x in it. So I'd probably use this one, solve for sine squared x. And so I'm looking at it and I'm thinking I might just subtract the 1. Cosine 2x minus, be careful because it's not 2x minus 1, it's cosine 2x minus 1, is negative 2 sine squared x. And then if I divide by -2, or multiply by -1/2, same thing, -1/2 times cosine 2x minus 1 is equal to sine squared x. This negative, I will distribute it. I like to leave the 1/2 out in the front, but once I distribute that -1, they're going to flip, or I can flip them because 1 is going to be positive, cosine 2x will be negative, so 1 minus cosine 2x. There's an identity. You probably did not see it in trig class, but it's one that we use a lot in 1552. I could have taken cosine 2x equals 2 cosine squared x minus 1 and solve for cosine squared x. See, so if I do that, I'm going to add 1 to both sides. Cosine 2x plus 1 equals 2 cosine squared x. And then I'm going to multiply both sides by 1/2. And just to make it more in line with what I wrote up here, I'm going to put the 1 first. 1 plus cosine 2x, so 1/2 times 1 plus cosine 2x is cosine squared x. And so you can remember these two. Sine squared x, you got the minus sign. Cosine squared x, you got the plus sign. And so that should help you remember those.